Welcome back to the deep dive. You know how this works? You provide the source material, and this time it's some pretty dense technical exam prep stuff for Veritas NetBackup 8.1.2 and the 3.1.2 appliances.
That's right. And our job is to pull out the absolute must-know bits for you.
Yeah, we're essentially creating the cheat sheet from this high-stakes certification guide.
And what's great about using material like this, is that it cuts right to the chase. It tells you exactly what matters for keeping these complex systems running smoothly. No fluff.
Exactly. The source material breaks it down into 4 key areas: configure, monitor and maintain, tune, and troubleshoot.
So we're going to walk through those and really highlight the core technical functions and those specific configurations that are make or break for reliability.
Let's jump right in. Where else to start but the heart of it all, the NetBackup master server.
The brain of the operation, absolutely.
Now, we know it's central, but the source material actually spends quite a bit of time on what the master server doesn't handle. Why is that distinction so important?
Well, it's about understanding its core focus. The master server's essential role, architecturally speaking, is managing job scheduling and, critically, maintaining that central catalog database.
The catalog.
Yeah.
That's the record of everything, right? Every backup.
Exactly. It's the absolute source of truth for what's protected. If your master server goes down, you're effectively blind. You can't find anything to restore.
So it manages the what and when, the policies, and the index, but not the actual heavy lifting.
Precisely. It delegates. It absolutely does not handle the high-volume data movement itself. That's for the media servers.
Okay.
And it doesn't do client-side deduplication processing, nor does it manage the appliance's underlying OS. It needs to stay lean and responsive for scheduling and catalog lookups.
Makes sense. Keep the control point focused. Don't overload it.
Yeah.
Okay, let's shift to monitoring the physical side. You're on call. Something seems off with tape access. You need a quick status check on the robots, the drives.
Right, and you probably don't want to wait for the Java GUI to load, especially if things are acting up.
Definitely not.
In that scenario, you drop to the command line. The primary tool highlighted here, the go-to utility for checking the state of robotic libraries and media, is vimo parsemd.
Vimo parsemd. Why that specific command? What makes it the essential one?
It's fast, it's direct, it gives you the immediate status of the drives, the robots, the media within them. Is a drive up? Is it down? Is the robot busy or idle?
So it helps you quickly isolate if the problem is with the physical hardware, the tape infrastructure itself.
Exactly. Before you start digging into network issues or policy configurations, vimo parsemd tells you if the basic physical components are even available and ready. It separates infrastructure from policy problems.
Okay, that's a really crucial command line tool to have in your back pocket.
Yeah.
Let's move from architecture and monitoring into configuring and tuning. Stability is key here.
Yeah, and one of the classic headaches is network latency, right? Especially between clients and media servers over slower WAN links.
Oh, yeah. You get those jobs that run forever and just time out.
Right
Near the end, usually.
So frustrating. So when you need to make the system more patient, basically tell the client to wait longer for a response from the media server during that data transfer. What setting do you tweak?
There must be a specific timeout value for that.
There is. It's called the client read timeout. This is the knob you turn to improve stability over those slower, higher latency networks.
Client read timeout. And where do you find that? I imagine it's buried somewhere in the host properties.
It is. You need to go into the client host properties for the specific client experiencing the issue, and you'll find the client read timeout setting there.
Okay.
You increase the default value, giving that transfer more time to complete successfully, rather than being killed off prematurely by network lag. It's about configuring patience.
Got it. Essential for remote offices or, cloud links. Okay, sticking with performance, let's flip from stabilizing slow transfers to actively troubleshooting them. Backup's running, but it's just crawling.
Right. Not timing out, just incredibly slow.
And you suspect a bottleneck, maybe on the media server side, during data writing. You need more detailed logs. Which specific process logging do you increase on that media server?
For data throughput issues, specifically how fast data is getting written to disk or tape, the process you need more verbose logging from is the media manager process.
Media manager, and the process name itself.
You'll typically see it referred to as VMD in the logs and documentation. That's the media manager daemon.
VMD. Why is that the key one for slow data transfer rates?
Because VMD is the layer that's actually talking to the storage devices, the tape drives, the disk storage units, the dedupe pools.
Ah, so it sees the direct interaction with the storage.
Exactly. If the bottleneck is slow disk I/O on the storage unit, or maybe contention getting access to a tape drive, the VMD logs, when cranked up, will show that. It helps you determine if it's a storage problem or maybe something else, like the network between client and media server.
Makes perfect sense.
Yeah.
Okay, now let's talk about making backups not slow. Let's talk about speed and efficiency with NetBackup Accelerator.
Ugh, Accelerator, yes, a really powerful feature for slashing those full backup windows.
It feels like magic sometimes. You get a full backup recorded, but it runs almost as fast as an incremental. How does it do that? What's the core technology?
The key mechanism, the sort of secret sauce behind Accelerator, is changed block tracking, usually abbreviated as CBT.
CBT. Okay, so instead of scanning every file, like a traditional full backup does, to see what's new or changed, what's CBT doing?
CBT works at a lower level. It leverages capabilities in the file system or virtualization layer to keep track of which blocks of data have actually changed since the last full backup.
Blocks, not files.
Right. So during an accelerator backup, NetBackup asks the CBT mechanism, okay, which blocks changed? And it backs up only those changed blocks.
But it synthesizes it into what looks like a full backup image for recovery.
Exactly. You get the recovery, simplicity, and speed of a full backup, but with the data transfer volume closer to an incremental. It's about being smarter, not just working harder by scanning everything.
Very clever. Okay, let's extend that efficiency idea into replication, specifically using storage lifecycle policies, or SLPs, and auto-image replication, AIR.
Right. SLPs automate moving backup data around, maybe from disk to tape, or replicating it. And AIR is specifically for replicating between different NetBackup domains, like from your main site to a DR site.
So let's say you set up AIR to replicate backups to your disaster recovery domain. And at that DR site, you have a specific storage unit, maybe a dedupe pool, that you want to reserve only for these incoming replicated images.
Good practice. You don't want local backups at the DR site accidentally filling up the space meant for critical replicated data from production.
How do you enforce that? How do you lock down that storage unit?
There's a specific checkbox on the storage unit configuration itself. It's a restriction option called Only Allow Replication Jobs.
Ah, okay. Pretty explicit.
Yep. You check that box, and that storage unit will reject any job trying to write to it unless it's an incoming AR replication job. Ensures that capacity is dedicated.
Smart. Now, what about when things go wrong with replication? Say, the network link between your primary and DR site is down temporarily, or the DR domain itself is offline for maintenance. Your error replication jobs start failing.
Right. You don't want those failures to just pile up and be forgotten. You need the system to automatically retry.
Exactly. How do you configure that persistence within the SLP?
You configure a maximum job submission interval in the storage lifecycle policy definition. This setting tells NetBackup how long it should wait after a replication operation fails before automatically trying to submit it again.
So it builds in that retry logic.
Precisely. It handles those temporary outages gracefully. Instead of just failing permanently, the SLP waits for the configured interval and tries again, and keeps trying until the remote destination becomes available. It adds resilience.
Okay, that makes sense. We've hit architecture, monitoring, tuning, efficiency. Let's talk security and appliance management to round things out.
Absolutely critical in modern environments. NetBackup security model has shifted significantly towards certificate-based trust.
Right, moving away from older methods. So when you're working within the security management section, specifically with host management, what's the main goal there? What are you actually doing?
The primary objective of using host management is to manage and deploy the certificates that enable secure communication between all the NetBackup hosts, the master, media servers, and clients.
So it's all about establishing that chain of trust using certificates.
Exactly. It ensures that when hosts talk to each other, they can verify identity cryptographically and encrypt the communication. It's fundamental to secure operations now.
And once you've set up that trust, you've deployed certificates,
Yeah.
where do you go to actually check the status? To verify that the security relationship between, say, the master server and a particular client is valid and healthy.
The definitive place for that is the security management section within the main administration console.
Okay, not buried in host properties somewhere else.
No, security management gives you that centralized view. You can see the certificate status, the trust level, expiry dates. If a client suddenly can't communicate securely, that's where you look first to diagnose trust issues.
Good to know. Centralized security status. Finally, let's touch on the physical appliance hardware. Say you need more storage. You physically rack and cable a new expansion storage shelf to your NetBackup appliance.
Right, you've added the hardware.
Before NetBackup software can actually use that new storage, the appliance itself needs to recognize it. What's the mandatory interface you have to use to trigger that hardware rescan and detection?
You absolutely must use the appliance shell menu. This is often just called the CLISH for command line interface shell.
CLIH, not
Yeah.
just standard Linux commands like fesc or something.
No. The appliance has its own managed environment. For hardware changes like adding a storage shelf, you log into the CLISH and use its specific commands to rescan the storage configuration. That's how the appliance OS properly discovers and integrates the new hardware before NetBackup can even see it.
Got it. Use the dedicated appliance interface for appliance hardware tasks. Let's wrap up with that provocative thought for you, our listener. We've established that NetBackup Accelerator using changed block tracking, CBT, fundamentally changes how a full backup works by focusing on changed blocks, not scanning all files.
Right, that shift from file-level scanning to block-level tracking.
So considering that reliance on tracking blocks, what inherent risk or maybe dependency does that introduce into your disaster recovery strategy? Does relying on block tracking instead of, say, a full file verification change how you should think about auditing the integrity of your backed up data?
That's a good question. Does efficiency potentially mask something you'd catch with older methods?
Exactly. Something to think about. How does this high-efficiency block-level approach affect your confidence and your verification processes? Ponder that one. Thanks for diving deep with us today.
Yeah, thanks everyone.
We'll see you next time.